Hello everyone. For today's video, we will be discussing about the law of sines. These are very helpful in solving oblique triangles. And oblique triangles are the triangles that are not right triangles. First, let us show the proof of law of sines so that we'll be able to understand how these ratios or relationship on the sine of the angle to one another. So let's say here, for example, we have a triangle which is not a right triangle. And we have here angle A and angle B together with their opposite sides, which are side B and side A, respectively. So we have here two given angles and their opposite sides. And take note that we have also drawn an altitude right here. So let us label that X. To show the proof on the law of sines, we'll be using the trigonometric ratios. So specifically, since we are talking about law of sines, then we'll be using the acronym SAW. Since we have drawn an altitude X, or we can show that the relationship of sine angle B, which is from the acronym SAW, opposite over hypotenuse. So that means sine B is equal to the opposite side, which is X. The hypotenuse is the opposite of the right angle, so that is A. So sine B is X over A. And if we wish to manipulate this equation by isolating the variable X, then we must multiply both sides by A, so that A will cancel out on the right side and we are left with X is equal to A sine of angle B. Okay, so let us take note of that. And then for angle A, right here we have, as we can see on the illustration, sine A is equal to the opposite side, which in this case is X, all over the hypotenuse. So we're referring to this right triangle here. And opposite of the 90-degree angle is B. So that is the hypotenuse. So that is X over B. Now, if we want to isolate X as well by multiplying both sides by B, so this will cancel out. And we will have X on the right side and B times sine A on the left side. And with that, we can show that X here is equal to B times sine A. So we have here two values of X. We have B times sine A and we also have A times sine B is equal to X. Therefore, by transitive property of equality, that if A is equal to B and B is equal to C, then by transitive property, A is equal to C. So this is by transitive property. So by applying that, we'll be able to understand that if we are going to apply that concept by transitivity, B times sine A is actually equal to A times sine B. And of course, by dividing both sides by A, if we are going to divide both sides by A, this will cancel out. And then, if that is B sine A over A, then we have here sine B. And by multiplying both sides by 1 over B, B will actually cancel out on the left side. So, by simplifying that, we are left with sine A over A is equal to sine B times 1 over b, so that is sine b over b. So here you go, ladies and gentlemen, this is your law of sines. So by the proof on the law of sines, we were able to prove a portion of the law of sines, which is sine A over A is equal to sine B over B. And if we are going to add another angle, let's say C in here, so this is angle C with the opposite of side C. So if we are going to draw another altitude right here, and it will create a right angle just like we did in the beginning of this proof, then we will be able to arrive at this law of sines. So in summary, if we are going to follow the steps such as what we did in the beginning, we'll be able to show that sine C over C is equal to sine A over A and then sine B over B. So this will be your law of sines. Thank you so much for watching and see you on the next videos.